Welcome to qnawire.
So we have a circular loop with a radius r of 0.15 or 15 centimeters or 0.15 meters, containing n number of turns equal to 250, carrying a current I of 2.0 amperes. It centers at the origin, and its axes lie along the x-axis. It wants us to calculate the magnetic field B at a point x on the x-axis from x equals negative 40 to 40 in steps of 2 centimeters, and make a graph of B as a function of x. Okay, so well, first, in order to do that, we need to know the equation that we're going to use to plug in. Well, the magnitude of the magnetic field due to the magnetic dipole at a point on its axis is going to be equal to B, and that's going to be equal to number of turns N times magnetic permeability of free space, mu naught, 4 pi, which is equal to 4 pi times 10 to the minus 7, times the current I, times the radius in meters squared, divided by 2 times r squared, plus x squared, and x is what we want to range from minus 40 to 40, all to the 3 halves. Okay, so we simply plug that into a graphing calculator and generate it by steps of 2. That's too much for me to write out every single thing here, but what I'm going to do is I'm going to plot what the graph looked like. Okay, so the maximum magnetic field that it returned here would be just a little bit more than 2. 2.1 is the maximum that it generated at x equals 0. So what we have here is the x-axis and the b-axis. So we just plugged in different values here from minus 40 to positive 40. Since that x value is squared, you might guess that it's going to be some kind of Gaussian or normal distribution. This goes to a maximum of 2. Let's go ahead and plot it in red. So it looks something like this. It went up, above. Oh, let's draw a little bit better. I want to draw the curve really nicely here. A little bit above, and then it started to go back down like that. And that's about what it looked like.